We often interpret shared phantom visions as paranormal events. In reality, these collective experiences are a predictable glitch, a specific processing error that indicates a high-functioning human brain operating under extreme conditions. Modern neurological laboratories allow researchers to isolate the specific feedback loops that govern perception. By stripping away environmental noise, they can deconstruct the brain's predictive software in real time. This investigation centers on a paradox in our firmware. The human mind generates a shared, vivid reality that observers can agree upon, even when there is no physical matter to support the vision. Perception is a controlled hallucination. Rather than recording the external world, the mind actively projects a model of reality from the inside out, constantly balancing its own expectations against incoming data. This internal projection system becomes visible when we eliminate valid external signals. The Ganzfeld effect achieves this through total perceptual deprivation, while Ganzflicker overloads the visual cortex with high-frequency strobes. Both states force the brain to process a data vacuum. Subjects report the same phenomenon, the manifestation of Kluver form constants. These geometric patterns, tunnels, spirals, honeycombs, are the brain's attempt to render order. This geometry maps neural activity. Aberrant waves of excitation spread across the visual cortex, which the brain interprets as a valid signal. The brain demands structure. It fills the sensory void by manufacturing these shapes, prioritizing any pattern over the chaos of pure noise. The human operating system meets a sensory void by aggressively hallucinating its own internal geometry, a baseline survival response to total environmental uncertainty. This is the Bayesian brain model, suggesting perception is driven by active top-down predictions called priors. Here, the massive downward flow of existing beliefs overpowers the small upward signal of raw sensory data. At their intersection, the brain calculates a prediction error, the mathematical difference between what the firmware expected and what the optic nerve delivered. This system utilizes precision weighting to manage ambiguity. The brain acts as a high-speed filter, assigning immense importance to vague noise and filling in visual gaps with its own best-guess projections before the signal reaches conscious awareness. This visual processing hardware is designed to overwrite reality with its own expectations. By minimizing surprise, the brain reduces the energy cost of navigating a complex and unpredictable environment. If the brain can hallucinate any form to fill a void, why does it specifically prioritize complex illusions like faces or predators? Evolutionary survival favors sensitivity over specificity. It is biologically safer to mistake a rustling bush for a predator than to miss a real threat. On a neurological timeline, within 160 milliseconds of seeing an ambiguous shape, the fusiform face area aggressively fires a false alarm. By the 250 millisecond mark, the brain verifies the stimulus identity, and the perceived entity resolves back into an ordinary object. Pareidolia is a conserved ancestral survival mandate. It is a system designed to temporarily override modern logic in favor of rapid, life-saving detection. This evolutionary hardware explains why we see faces, but it doesn't explain why isolated individuals often see the exact same faces. Data from 2026 neuroimaging studies reveals that unstructured white noise forces the brain to rely entirely on top-down semantic knowledge. Without bottom-up cues from the natural world, the mind reaches into its own conceptual library to resolve the image. Because humans share identical cultural and semantic frameworks, we pull from the same internal blueprints. This reliance on shared concepts biases our hallucinations towards standardized, human-created forms when the lights go out. These shared entities are standardized glitches in the human source code, proving our seemingly private, subjective minds share an identical architecture for rendering reality. The boundary between a common glitch and clinical delusion is defined by the algorithmic weighting of prediction errors. In psychosis, top-down priors gain enough weight to crush and override contradictory sensory evidence. The internal model becomes more real than the physical world itself. synthetic media and AI-generated content exploit these hardwired neurological shortcuts. This artificial data hijacks the brain's natural pattern recognition firmware by mimicking the specific signals our systems evolved to trust without question. We simply cannot uninstall this evolutionary software. However, understanding its desperate biological mandate for order provides a framework for identifying when our perception is being manipulated by external inputs. Recognizing reality as a best-guess projection is the first step in mastering the glitch. To explore more investigations into the systems that define our world, subscribe to Tembodocs.